Thank you for joining this lesson. We're going to study physics, refraction of light, number 16 of the paper, whereby we are told that a single ray of light is incident on an equilateral glass position as shown in the figure below. Complete the diagram to show the path of light through and out of the position. Critical angle of glass is equal to 42 degrees. Remember to subscribe to this channel and to also share the link with friends. Therefore, a few things have to be known about refraction of light. It should be known that if a ray of light is incident to a certain interface of two media such that the ray is perpendicular, it should be known that the ray passes undeviated. So this ray is not going to be refracted, it will pass undeviated up to that other interface. This is how the ray passes. Now that this is 90 and this is 60, then the angle here is going to be 30 degrees. Now, if this angle is 30 degrees, we can draw a normal at this point of incidence such that the normal is perpendicular at the point of incidence. This is a normal. Now, with this normal, the angle of incidence for this ray, which is refracted, but now it becomes incident for this interface, so that this angle becomes 60 now that we have 30 here. Now, this angle of incidence is greater than critical angle of glass, which is 42 degrees. Therefore, we usually say when angle of incidence is greater than critical angle of a given medium, total internal reflection occurs. Therefore, what will happen is that the ray will not emerge outside. It will be internally reflected such that the angle of reflection now, is going to be 60. Remember, this was refraction, but now we are having reflection internally, such that if this is 60, then we got a 30 here. And because the glass is equilateral, we're going to have 60 degrees at this point. 60 degrees, making this one 90. Now that we have again the same ray reaching this interface at 90, it should emerge now undeviated. Therefore, this ray will proceed now undeviated. So that is how the ray will emerge out of the medium. The next question is telling us to state two conditions necessary for total internal reflection to occur. One condition necessary for total internal reflection to occur, it should be known that for reflection to be totally internal, we need angle of incidence in the denser medium. The denser medium must be greater than the critical angle, than the critical angle. Number two, the rays of light must be traveling from an optically denser medium to optically less dense medium. So the ray of light must be traveling from optically denser to optically less dense, because during the optically denser and optically less dense, when we have the normal there, then the ray which is incident, it's the interface at that point. The refraction in this case occurs this way, away from normal. It bends away from normal, which means at some point the ray will get totally internally reflected, as opposed to when it is from optically less dense to optically denser medium. In such a case, the ray is refracted towards the normal, and there are no chances of total internal reflection occurring. Let us look at number part C, Roman 1. The figure below shows an object at the bottom of a beaker full of liquid. So an object is here at bottom of a beaker full of a liquid. An observer above the beaker sees the image at position X. So this image is now seen at this point X. Point X is 40. Sorry, this is 10 centimeters from the bottom. Then now we are seeing from the top to the bottom, we are having 40 centimeters. 40 centimeters. Determine the refractive index of the liquid. For us to get refractive index, we need real depth. The real depth divided by apparent depth. Apparent depth. Therefore, in this case, the real depth is 40 centimeters divided by the apparent depth. Apparent depth is the depth we can observe from here to here, which is going to be 30 centimeters, since from bottom to top is 40, but from bottom to where the object is seen is 10. This one is called vertical displacement. 10 is vertical displacement, which means apparent depth is 30. Therefore, the refractive index of this liquid is 1.33. 1.33. Finally, define the term critical angle, small letter c, of a medium. Critical angle is the angle of incidence in the denser medium, optically of course, denser medium, for which the angle of refraction in the denser medium, in the optically less dense medium, is 90 degrees. The angle of incidence in the denser medium, for which the angle of refraction in the optically less dense medium is 90 degrees. State 2 uses of optical fiber. Now that optical fiber can transmit data across large distances, it can be used in communication. Optical fiber can also be used in the medical industry. It can also be used in defense. Can also be used in mechanical inspection, among other areas. Thank you for following. Subscribe and share.